Let's talk about instantaneous velocity. I put the word instantaneous in parentheses because after the first week, you're never going to hear it again. It's only going to be velocity. So the velocity is defined as the time rate of change in position, which turns out to be the same thing as the first derivative of the position with respect to time, which you can also find by the slope of the tangent line to the position time graph. Even if you're taking an algebra-based physics class, it still might be worth watching this video. Most algebra-based physics classes also do this. So even if you're not actually taking derivatives, the tangent line is just a line, and you can find the slope of a line without calculus. It's the rise over the run. I'll have a graph of that. So it's basically the average velocity, the delta x over the delta t. I think it's worth watching this video to see how it's related to the average, to see how the instantaneous velocity is related to the average velocity. The way that we write a derivative, the notation that we use looks like this. So that's the velocity symbol. That's my cursive V. That's my cursive V with an arrow over the top to indicate it's a vector. A derivative is written as d of the quantity in question, which in this case is position, dt. So that's a derivative with respect to time. The time is on the bottom and the variable at the top. So position and time, position and time, position, time, position, time. So you have to have both of what you're taking the derivative of, position in this case, and with respect to what variable, time in this case. That's the notation, but how do we actually do that? So what that turns out to be is it turns out that that is the limit as delta t goes to 0 of the average velocity, which we could write as delta x over delta t. So the instantaneous velocity, which is written this way with d's instead of delta, the average velocity is written with deltas. The instant velocity is written with d's, and that means take a derivative. The instantaneous velocity is the limit of the average velocity as we shrink the time interval. It's definitely worth saying a lot more about what that looks like. But for now, let me also just finish with the velocity is a vector. I've been writing a vector arrow over the top. It's a vector, so direction is important. And the units probably won't surprise you that they have to be the same thing as the limits, the units of the average velocity. They are meters per second in the MKS system.